Yeah, I'm Kate. I'm head of community and ecosystem at Phoenix. So I guess just to get started, raise of hands, who here knows what FHE is? Okay, very cool. And I guess, yeah, the second question that I always like to start with is, who here cares about privacy? Okay. So then my follow-up question to that is, anyone who didn't raise their hand, would you be willing to come up on stage, cast your phone to the screen and go through your recent transactions, your Visa bills, all of your DMs? Probably not. So I mean, that's kind of how I think about privacy, is that we traditionally think of privacy as almost a negative thing, as like you have something to hide, right? Like there's something that you want to keep from the world. You're acting nefariously in the shadows. But I think privacy is a lot more normalized today than we really think it is. And kind of applying this to blockchain, I've mentioned this in a bunch of talks before, but with blockchain, we've kind of taken the inverse approach as we have to building the rails of the internet, right? We started slow with the internet. We added these different networking layers, transport layer secure, TLS, secure socket layer, all of these compounded, to create privacy on the internet, which is what allowed for e-commerce, to take off in a big way. Blockchain is the inverse, right? We kind of shipped day one, and then retroactively we're like, oh, we should think about interoperability. How do these blockchains communicate with each other? Ooh, we should really start tackling, anonymity, privacy, confidentiality, now that, the big players like the institutions and the banks are coming on board in a meaningful way. So, we are kind of doing the inverse of what we really should have done. And so I guess that's the kind of the point that I want to get across today, is that privacy, most decentralized apps are architected for transparency by default, right? That was kind of the core tenet of Bitcoin that is, followed us along our journey to, to the Ethereum landscape of today. But that architectural decision defines your user base, right? And Ethereum it really is a glass house, right? All Ethereum state is public. Your balances, your votes, your bids, your preferences, all of your behavior. And this also opens up, the door to leaking sensitive data, right? Exposing your trading strategies. It invites, MEV exploitation. So in existing methods, right, like zero knowledge, multi-party compute, they don't necessarily support persistent encrypted state with flexible logic. And this creates, the $500 million problem. So in 2023 alone, MEV losses in DeFi, were above 500 million. 15 to 40%, auction value extracted, and 75% of this, and I think this is the key factor here, is that 75% were from losses from trades under $20,000, right? So these were like your not your whales, not your power users. These were your everyday retail users, the hobbyists. And so I think we're very much at a critical kind of inflection point in DeFi and in crypto, is that we've been talking about, mass adoption forever. We've been talking about it for over, the more than 10 years that I've been coming to these conferences, giving talks, listening to talks. And I think, now, like I said, we are at this very critical inflection point, because now we have institutional and enterprise kind of adoption in a really meaningful way, right? And so I know email was mentioned before, but back in the day, if you were sending an email, it was by default plain text, right? There was no encryption added to it. And so what you had to do is you had to manually sign each one of your emails with PGP, which stands literally for pretty good privacy, and that's exactly what it is, pretty good privacy. So the body would be encrypted, but the kind of the subject line, the sender, the receiver, all of that, metadata you were not able to encrypt that. And so that was kind of how we just operated, right? We had to manually encrypt your emails if you really cared, if you were kind of a privacy maxi back then. And the shift towards encrypting things end to end, the reliability of that in terms of the logging and all that can be debated. But the shift from plain text by default to end-to-end encrypted by default was really driven by enterprise adoption of email in the workforce, right? That's really what moved the needle. The cypherpunks obviously got us to where we are today. There was a very kind of vocal minority, but real change in terms of, like I said, end-to-end encryption being the norm for emails, for communications, that was really driven by, institutional demand, which we're now seeing, in a meaningful way, like I said, in the Web3 space. There's also a lot of regulatory pressure, right, with DAC here in Europe, with the Genius Act in the US. So privacy is a compliance enabler, thinking of this as a way to enhance regulatory, basically the ease of being regulatory regulatorily compliant. Stablecoin adoption, right? Everyone here, there's a lot of hype around stablecoins. There's a lot of governments adopting stablecoins and launching stablecoins, as well as RWAs. Like I think Korea has just launched their tokenizing gold, the Korean government, as well as launchpad evolutions, right? We're moving to sealed bid auctions. I don't know if anyone followed along with the Zama auction, but that's kind of the new way of like thinking about and approaching, TGEs and ICOs. So the window is open, and this is kind of, the point that I brought up before, right? From 2020 to 2023, the cryptographic readiness of these solutions, like FHE, zero knowledge, they were really not there yet, right? Like they were very kind of theoretical. Whereas now, right, the private shared state unlocks the production ready, right? Phoenix, we're in testnet, we're going to mainnet this year. Zama, Aztec, you're seeing these, these privacy preserving technologies actually going to mainnet, and we're seeing that they are production ready. The issue though is that, if you don't adopt privacy by default from the beginning, protocols ossify, right? Retrofitting is brutal. It is very, very difficult to kind of retroactively add privacy, to your design, right? So for institutions, it's an absolute requirement. No institutions are going to meaningfully come on chain unless there is a way to protect their trades, to protect their strategies, and to add privacy, and anonymity and confidentiality to their on-chain activity. It's a demand for traders. Like I said, the people getting hit by these MEV attacks are the smaller traders. It's these trades under 20,000. It's not the big whales. It's the everyday kind of crypto user. And then for compliance, we're having, for the first time, meaningful discussions about compliance, what that looks like. So privacy is going to have to play a huge role in that. And so, yeah, I mean, we're seeing new markets that are unlocked by the potential of really meaningfully adding privacy to Web3, right? Capital protection, right? Payroll. Nobody wants everyone to be able to see what they're getting paid. Contractor payouts, treasury moves, all of these expose your strategy. You don't want this to be public. You don't want this to be on chain. RWAs and compliance, right? Real estate ownership, valuation, being able to encrypt that. Transfer restrictions enforced at the decrypt layer via permits. These are all things that we're being able, to really actually build out for the first time now that can scale. As well as strategic coordination, right? Multi-party deals stay hidden until settlement, right? Mergers and acquisitions, these, only go public once it's ready to go public. Partnerships, really large trades like institutional trades, they can execute without people copy and trading or front running their trades, which is really one of the big blockers, like I said, to actual meaningful institutional adoption, of crypto. So confidential by design is kind of what we really preach, right? Privacy is a primitive, not as a feature. So when you start to think about privacy as a primitive and not as a feature, you understand the importance of implementing it by design from day one, right? It's very, very difficult to retrofit, right? Breaking changes to core logic. We had a hackathon, for example, with Uniswap, and we were developing some, FHE-powered hooks. We were in talks with Uniswap about ways we could partner, and they're basically like, it would break the core logic. There's really nothing that we can do, right? So building with privacy from day one, it gives you institutional grade architecture from day one that can scale, selective disclosure from day one, clean composability, again, regulatory ready. But if you don't, right, this technical debt compounds, right? Playing catch up is very, very, very difficult. And there's also user migration friction, right? By definition, and if you're kind of retroactively trying to fit privacy into what you're building, there is going to be this user friction because you do have to kind of break the core logic and add new flows for users, especially if they're very familiar with the product. This could be the difference between retaining users and them just hopping ship to somewhere else. So privacy enhancing technologies. I know there's a lot of acronyms in crypto. So, I mean, I'm sure everyone's heard of TE's, Trusted Execution Environment. This is an isolated hardware, right? Running code and managing data privately. The limitations there is that it requires trust in the hardware vendor, right? We've seen some hacks around TEs recently. MPC, right, multi-party compute, distributes computation across multiple parties without revealing individual inputs. But, there's obviously, some trade-offs there, like high coordination, communication overhead. Zero knowledge proofs, I think people are most familiar with ZK. One party can prove a statement is true without revealing the underlying data. Again, the composability of this is not great. It's difficult, to model the complex logic that's associated with it. FHE, which is what Phoenix runs on, fully homomorphic encryption, allows computation on encrypted data without needing to decrypt it. So fully homomorphic encryption, for those that are not familiar with it, homo is same and morph is change. Seems a little bit counterintuitive, but basically it's encryption that changes the plaintext into ciphertext that is structurally the same. So it allows you to compute on encrypted data that nowhere along the data's life cycle has to be decrypted. So before, you would have to, kind of decrypt this ciphertext into plaintext, compute on that, re-encrypt it, and then, broadcast whatever, logic or, rebroadcast to the chain or return whatever, functions that you're running on it. Whereas with, FHE, it allows computation to be done on encrypted data while remaining fully encrypted. So this means your data is hidden during the transit and processing the entirety of this data's life cycle. It does not ever have to be decrypted for you to compute on it. And so, for people that are familiar with FHE, it's been around for a very long time. It was kind of, deemed as like the gold standard of encryption, but there was a lot of issues, right? Like really in the last year, we've actually seen FHE become production ready. FHE was very complex, right? Now with Phoenix's co-FHE, so our coprocessor, our SDK uses the same patterns as WAGMI, right? So uint becomes EUINT. It becomes just an encrypted version of the function that you would usually call when you're writing a Solidity smart contract. FHE is too slow. Yes, it was very slow in the past. Xama's libraries have tackled this. We have a library that is in production right now called DBFE that has the potential for 10,000 TPS. FHE is in production ready. This was kind of the biggest one that we had to contend with. We are on testnet, but we're on Sepolia, Arbitrum, and Base. And like I said, Aztec and Xama, they've kind of paved the way for this. Our users don't care. Like I said, this, in general, I think people are a little bit apathetic, especially in this space, about privacy. But like I said, 75% of MEV losses hit these trades under 20K, right? So retail is really the victim, of this, of non-encrypted or unencrypted data. And this is also the big thing that we see is like, oh, we'll add it later. Institutions are evaluating now from an institutional perspective. First mover advantage is now, obviously, but like I said, it is very, very difficult to retrofit privacy into whatever you're building. So CoFi, so co-FHE, this is a fully homomorphic encryption coprocessor for EVM chains. This is actually new, so I think we launched about last month. So it lets smart contracts compute, like I said, on encrypted data, meaning values stay encrypted not just in storage, but throughout every single step of processing. So CoFi, sits off-chain, but it proves its work on-chain, right? So developers write contracts in Solidity, so a language that they're very familiar with. It's, sorry, Aztec, but you don't have to learn Noirlang, you don't have to learn, a new language. You can write in Solidity that you're very, comfortable with and familiar with. So the users they encrypt their inputs before they hit the chain, right? So the coprocessor, or co-FEG, that does the heavy lifting on the encrypted data, and it in turn returns encrypted results. So when decryption is needed, a threshold network of independent MPC nodes handle it. No single party ever sees plain text. I think that's really, the impressive thing about, CoFi or coffee. So yeah, we've got the smart contract, so it's the Solidity library, the client side, so our CoFi SGK, this is a JavaScript library. And again, we're writing these libraries out, right? So like the next move is to be live on Solana. We can write out a Rust library. Testing happens with these mock contracts, and then decryption, right, with a custom threshold network. So that's kind of the very high-level flow. This is kind of getting a little bit more into the weeds here, but encrypting the data, so contracts receive EUINT types, so encrypted UINT types, as inputs. Then to work with them, uses FHE as EUINT 64, for example, to convert them into usable EUINT 64 variables inside the contract. All encrypted math is done via the FHE library, fhe.add, fhe.sub, etc. And then access control must be explicitly set for each result with FHE.AllowThis. And this is set by, so access control list basically determines who can access the data and to what degree, what capacity. So access control, this is a very key kind of part of everything. So access control lists determines and cryptographically enforces who can decrypt data. This is very key, to kind of the functioning of Phoenix is, so you can grant, who can reuse this value in future transactions, a specific wallet that can decrypt this value, current transaction sender can decrypt, or anyone can decrypt. So it really lets you set the logic at the smart contract level. And then, what can you, I don't know how technical folks are here, but arithmetic, comparison, selections, and randomness. So these are all things that you can set that you have control over when you're writing out your smart contracts. I'll kind of move on to the next one. I'm not sure how technical folks are. But so decryption has two paths. So view decrypt, show a value in the UI. So this is when users want to see their own encrypted data, like your token balance if you're sending encrypted transfers. Requires a permit, and this is entirely off-chain. It returns a typed scalar for display only. Not sure if this means anything to anyone. But basically, there's no on-chain verifiable signature for this. And then there's transaction decrypt, which publishes a value on-chain, right? So this is used when a contract needs plaintext for logic, like token on-ramp, auction finalization, tallies, stuff like that. And this is when the threshold network returns a signature with plaintext. So the contract verifies the result on-chain before use. This is kind of, like I said, the very high-level kind of life cycle. So encrypt, submit, compute, decrypt. So step 1, the client encrypts. Step 2, contract operates on encrypted data. Step 3, the coprocessor computes. And then step 4, there's, you can choose between these two decrypt paths. So this is actually our head of developer relations, Lauren. If anyone has very technical questions, she'll be able to take them. But I guess just getting back, I'll move out there. Getting back to, to ACL, so the access control list. So this is kind of what we consider, the aha moment, right? On a standard EVM chain, all state is public, right? Anyone can read balances and balances at address. Kofi, that changes the default. Data is encrypted, and ACL determines who can decrypt it, which is then enforced cryptographically. So traditional blockchain privacy relies on access gates, who can call a function. Kofi's ACL controls who can see the underlying data, even if they call the same function, right? So it's a fundamentally different layer enforced at the cryptographic level, and there's no way to really read around it, right? So hacks become obviously not impossible, but very cryptographically different, right? So what ACL unlocks is confidential transfers, private voting, hidden game assignments, sealed auctions, and more. So basically, your smart contract determines exactly who can decrypt what at the cryptographic layer, not just who can call, the functions. So like I said, we are on testnet right now. Our roadmap is such that hopefully, if everything is on track, we go live in November of this year. Our plan is to go live with as many use cases on mainnet as we can. Obviously, private, token transfers are kind of the default that we're seeing a lot of. We're also seeing some really cool projects like privacy-preserving DeFi aggregators, encrypted asset management, confidential DEXs, a lot of dark pools, privacy-preserving lending, confidential payment protocols, and then some perp DEXs and some Uniswap v4 hooks. Confidential portfolio rebalancing, really the sky is the limit. Also stealth auctions, there's a lot of sealed bit auctions that we're seeing being built on Phoenix. And like I said, you don't need to learn a new language, you don't really need to learn new logic. It really is, if you understand Solidity, you can make calls to our co-processing library, encrypt the functions that you're already familiar with calling, and the EUIN eBool becomes encrypted with Phoenix's FHE library. So I didn't realize I had more time than this, but that is my talk. Like I said, if you take one thing away, it's that privacy should be by default. It should be something that you don't even think about. The end user shouldn't understand how it works. It should just work very well, hidden under the hood, hopefully secured with FHE. and that it should not be an afterthought. It's a primitive, kind of not a feature that you add retroactively, because trust me, it is very difficult to do. So yeah, that's my talk.
Thank you, Kate.
Cool. All
Thank you,
right.
Kate. Any questions?
Perfect.
No questions?
It was all super clear then. Oh.
Maybe I've missed that, but what are the current limitations of the fully homomorphic encryption?
So the current limitations, so yeah, I did kind of glaze over that. But yeah, I mean, it's complex. It's very complex to design around branching logic. That's something that's very difficult. Asynchronous execution model is a little bit difficult for people to wrap their minds around. And we are working on improving this, but there is still a higher compute cost to other solutions like zero knowledge and TE. So those are kind of the three main ones. Yes. I did glaze over those, but yeah, those are the limitations that we're seeing right now. And latency, like it is slower than other solutions, but like I said, with DBFE, our novel cryptographic FHE library, we are working, the engineers, not me, are working very hard to address that.
Kate, here.
Yes.
What do you think about the tension between the cryptographic, theoretical cryptography and the necessity of people are saying right now, privacy is not enough, and it will be this always the tension between like, can we have one day the ultimate holy grail of privacy, or there will be always this kind of like applied cryptographers pushing things forward, then the product managers pushing UX forward, but then it will be never like a perfect solution. Like, what's your opinion on those two things?
Yeah, I mean, I don't think perfect solutions exist. I wish there was one, because we'd all just be adopting it and none of us would be having any of these discussions. But I mean, Phoenix, like, we're not in L2, we're not in L1, we are infrastructure, right? So all we can do is provide the best developer tooling to create the most seamless experience for coders to, and developers to write these programs. Continually building out our cryptographic libraries that are powering FHE. Like the fact that people can vibe code with Phoenix, I think is incredible. And I know there's a lot of contention between TE, MPC, ZK versus FHE. I think, the pie is still too small to really kind of pick one hill and die on it. I think there's a place for, in terms of use cases, there's place for everyone, right? There's utility for everyone. All we can do is make sure that the developer experience is as seamless as possible. The cryptography that underpins, the encryption is as kind of robust as possible. And then in turn, that gives the end user the best experience possible, right? I don't think we're there yet. I think there are still some trade-offs between UX and the underlying kind of cryptography and, technical solutions. I wish, like I said, I wish there was one perfect solution. In the future, I hope it'll be Phoenix. But yeah, there's no one perfect solution, but all we can do is kind of marry those three elements and produce, the best solution possible, which I think, I'm biased, is Phoenix.
Well, sorry, we're out of time. I'm sorry.
We can chat after.
Thank you,
Cool.
Kate.
Thanks, guys. Oh, we're done?
No, that's it.
No?
Thank
Okay.
you.
Cool.